Hello students. Today the topic that I found important for you all, particularly for your BTech and your GATE and subsequent examination, I think that the topic that I have chosen would help you all, and the topic is searching. Searching is basically at initial level categorized in two categories. The first category is your linear search, and the second one is your binary search. See, whenever we talk about algorithms, we talk about two types of algorithms, two parameters we talk about. The first parameter that we talk is the time part, and the second parameter that we talk about is the space part. So basically, a searching algorithm also is associated in these two categories, the time complexity part and the space complexity part. So in detail we will study these two algorithms. Not in the same video we will discuss the algorithm and the complexity. The algorithm will be discussed in this video and the complexity will be discussed in the subsequent videos that will come. Since I think that the video should not have too long so that the concentration of the student can go, so I have made this video short so to have the linear and the binary search. That's it. See, searching means what? Searching means to find or to locate a value in a structure. The structure can be an array like this, structure can be an array like this, or it can be a linked list also. Both can be used with a searching algorithm, but for simplicity of the algorithm, we will go for the array part. The linear search says that if this is an array and these are the index in the array, these all are the index in an array, and if I want to search a particular value, since consider these all are the values in the array, these all are the values in the array, and I want to locate a particular value in this array. The value that I want to locate is being represented by a variable name item. Now I want to find whether this item is available in that array. Question number one. Question number two, if available, where it is actually available, the physical location of that variable. And the third, if not available, then an error message will be printed. So a linear array, the word linear array means whenever we try to locate an element one by one, that is first, then second, then third, then fourth, then fifth, and so on. Whenever I try to locate the element one by one in an array in a sequential manner, that is known as a linear array. The benefit is that simple concept, no need to have the data, the array in a particular order, not required. We can take data from any array. Problem, the algorithm will give a result as the length of the array grows. As the length of the array grows, the time complexity of the algorithm will increase. Means if there is only one element, it will provide you the faster one, and if there are n elements, say 10,000 elements, the time to find an element in that array using a linear search will take considerably more time. Okay, and in terms of algorithm analysis, if I use this word, then I will write order of n, a big O notation. This we will discuss in detail in the next video. But for comparison of the algorithm, I am using only the term, that is big O notation, and the big O notation of this algorithm is order of n. That's it. Now, linear search has one benefit also, that if the element that you are looking for is available in the initial part of the array, then also this algorithm has a very good response rate, a very good time complexity. So we conclude two things. First, if the size of the array is limited, then also we will get a good result. And second, if the size is large, but the element that we are looking for it at the initial part of the array, that also is beneficial for us. Next, the next algorithm, that is the binary search algorithm. Binary search algorithm required that the array should be in an order. That is, it required either the array should be in ascending order, or it should be in a descending order, or it should be in a descending order. Either order will work. Second, the complexity of binary search is more acceptable as compared to the complexity of the linear search. Okay, and the time of finding an element in a binary search is having a complexity of order of log n, log base to n. Okay, now these two facts, that how I have calculated order of n, how I have calculated order of log base to n, this I will have a dedicated video on this on the next video, but now we will concentrate on the algorithm part. See, algorithm is what? A step-by-step process to solve a particular problem. And a pseudocode is what? The code, something between the core programming and the algorithm. So I think that if I go for a pseudocode, if I go for a code with an algorithm, I will make the points more clear as compared to writing the algorithm blindly. Okay? So without wasting time, we will start our first algorithm of concern, that is the linear search. In linear search, what are the steps that I have to perform? On the one end of the screen, I am writing the content of the array with the index. So for example, the contents are like this. The second point, we will conclude that the element is found in the first encounter of that element. Means we will not recursively found all the occurrences of that element. It is up to us whether we found the first occurrence or we found all the occurrences of the element. So I am writing this algorithm come pseudocode, keeping in mind that as soon as I get the first element of that particular item, I will break the searching algorithm there only. Okay? So I have an array. The name of the array is A. The values are like this: 7, 5, 2, 8, 1 and 10. Now I have to find an element, and that element is int item, and I have taken that element for simplicity is 8. Now what I have to do is that I have to have a loop. That loop will start with 0. Since the array in C, C++, most of the languages starts with 0. If any other language have any other indexing, we can go for that, but majority of languages starts with 0, so we are starting with 0. The next is I is less than the size. So what is the size? 1, 2, 3, 4, 5, 6. The total elements are 6. So I is less than 6. Then I++. Now, each and every element will be compared with item. How to do that? I will write if item is equal to AI. That means if the item is available in the ith position of an array, where the ith value starts with 0 and ends with 5, if at any position it founds, then straightforward I will print here, printf, I will print the particular location, that is I+1, where it is found, and I will terminate here. Now it is up to you to whether to terminate an algorithm as soon as a value is encountered, or to print all the occurrences of that element. It's up to you. You can decide what to do. Okay. Now I will end the loop. This is an algorithm, a pseudocode particularly, of linear search, where we start from searching with 0 and with 5 if not found, then we compare the element item with the ith element, that is the 8 will be searched in the position 0, not found, we will go to the element number item number 1, not found, We will go for the item number 2. The value is also 2. Not found. We will go to the item number 3. The value is 8. It is the desired value. We were searching for item. The value of item is 8. It is located here. That means that our search is successful. That's it. What I was searching, I have got that value. I have searched that value. Then that particular value get printed I plus 1. Why I am printing I plus 1? Because I am printing in the term of normal English, normal maths, first, second, third, fourth. But the index is in the form of 0, 1, 2, 3. So the thing that is 3 is actually 4 in our terms. So I have used the word I plus 1. And the break statement, that is the element that I was looking for, is basically found, and I don't want to see all the occurrences, therefore terminated. This is a basic example of a linear search. And why I am using the complexity n? Because this algorithm is executing 5 times. Why it is executing 5 times? Because the value of n is, it is executing your 6 time. Why it is executing 6 time? Because the total number of element is 6. So the maximum number of time the loop gets executed is equal to the size of the array. Therefore, the order of this algorithm is order of n. The worst case, the order of n. Okay? Now, we will go for the binary search. Now, after discussing the linear search, we move towards the binary search. Because see, we cannot afford to waste time which is in the order of n. You will think that is not very large enough of time, but it is large. If I am talking about the value of n is equal to 10 lakh, if the set of data is 10 lakh or 1 crore, it is a very large set of data, and this large set of data have to be searched in some more mathematically correct technique. And for that, there is a very famous technique, and that is the binary search. See, why it is binary? The first question, binary. Why is binary? Binary means 2. Why it is 2? Because at every level, the list is divided by 2. That means if I start with 20, at the second level, we have a set of 10. Then at the next level, I have 5, and then 2, and then 1. That means it is exponentially reducing in the power of 2. That is 2 to the power k. That is in the value of k. That is at the first iteration where the value of k is 1, it is being divided into 2 parts. That is 2 to the power 1, 2 parts. In the second iteration, the value of k is 2. Therefore, it is divided into 2 to the power 2. That is 4 parts. In the next iteration, the value of k is 3. Therefore, 2 to the power 3, and 2 to the power 3 means 8 different blocks. And this is the power of binary search. There is one prerequisite for the binary search. And what is that? Binary search requires that the array should be in an order, whether it is a ascending order or it is a descending order, you decide, but it should be in an order. Now, if I talk about the binary search, let's first understand how it works in a non-programming manner. See, if this is an array, okay, if this is an array, this is the index. Total we have 11 elements. So for simplicity, we go to 11. That is total we have 12 elements. And the values are, for example, 2, 4, 8, 9, 10, 15, 20, 25, 28, 29, 35, 36. These are the values. The first thing what I have to do is that I have to mark this particular index as L. L means the lower index. The second element U. U means the upper index. Okay. At any moment of time, if the value of L is in the bound of U, means if L is less than equal to U at any moment of time, that means that everything is fine. You can repeat the loop, you can go for the iteration, everything is under control. That means the element that we are looking for is available there. At any moment of time, if the value of L is greater than U, this indicator indicates that now the element that we are looking in that particular array, it does not exist, because this condition only initiated if that element is not in the array. So the condition that we will think of is L less than or equal to U. So the first thing is that. The second thing is that we will go for mid is equal to L plus U by 2. L plus U by 2. Don't get confused that what will happen if the value is 2.5, what will happen if the value is 3.5. Don't get confused. Either you promote or you demote. In both the cases, the algorithm will work. That means either you go to the lower side or you go to the higher side. Both the cases it will work. We will go for the lower side. The third thing is that at every iteration, I will check the item if it is available in A mid or not. If the item is available in A mid, if the item is available in A mid, that clearly means that the item that I am looking for is available in that particular array. So this is the breaking condition. We will print with the success and I will terminate the loop. But if it is not there, then we have two possibilities. For example, if I am searching for say 20, okay, and the value that I am looking for is say 24. I am going for 24. When I check with the midpoint, for example, the midpoint is 6. If I check the 6th position value, which is 20, is not equal to 24. That simply means that the element that I am looking is not in the mid. So now I will not say that the element is not available. What I will do, I will divide the list in two parts. The first part will be from where? The first part will be from L is equal to 0 to U is equal to mid minus 1. This is the first list. And the second list will be L is equal to mid plus 1 to U is equal to say 9 or say we have 11. Okay, that means the list will be divided into two parts. One will start from 0 to mid minus 1, second will start from mid plus 1 to the last. In this case, in this particular case, the item that I am looking for is 24 and 24 is greater than 20. That means item is greater than the mid one. So the second list, the second part will be considered. That means the value of the L will be treated as mid plus 1 and the value of U will be unchanged. For example, if in place of 24 we are having a value 18, in that case what will happen? In that case we will go for the right, we will go to the left side. That is, since 18 is less than 20, so the value of the lower index will remain to be 0 and the value of the upper index will be mid plus 1. So the element that I am looking for will be available something between 0 to mid minus 1. So the search will be lie in between and the same thing will be repeated. One important thing to be considered is that this problem is basically, this technique is basically a recursive technique. So the solution, if we go for the recursive solution, then it would be more easy to understand and we will get the more benefit from that. If we go for a non-recursive technique, since the problem is recursive, if we go for the non-recursive technique, the complexity will be high and the entire algorithm will become complex. So in the first part of the video today, I will not go for the recursive function because I have not make you understand what the recursive function is. So I will go for a normal procedure, but in the subsequent videos, I will explain the recursive function and then I will explain the binary search with the recursive function. So what would be the pseudocode for that? The pseudocode says that the value of L will be 0, the first value is 0. The value of the U will be n minus 1, where n is the size of the array. The condition that I will monitor is L is less than or equal to U. I can go till U, but I cannot cross U. Within that, what I will do, I will write mid is equal to L plus U by 2. So I got the mid value. Then what I will do, I will check is A mid equal to item. If A mid is equal to item, if A mid is equal to item, that means the element for which I am looking for is available. Then what I will write? I will write printf, then I will write %d to indicate where I have got the item, then I will write mid plus 1. Again, I will go for break because I use this searching for the first occurrence. If you want to have all the occurrences, don't go for break. You can eliminate the break, but the algorithm basically says that to print the first occurrence where the item is found. So I am printing the first occurrence where the item is found. Now, the possibility is what? The possibility is that the item is less than the mid one. What does this mean? This means we have to go for the left side of the list. How to go for that? For that, L will not be changed. U will be updated to mid minus 1. And if it is not equal, if it is not less, obviously it is greater. That means the list will be on the right side. In that case, what I will write? I will write L is equal to mid plus 1. So, I have three possibilities. First possibility is found at the mid. Straightforward found, break, success terminated. Second possibility, left hand side, no change in L, U will be changed, U will be updated to mid minus 1. Third possibility, it is greater, U will not be updated, L will be updated to mid plus 1. Okay? Now, apart from this, one more thing I would have to use, and what is that? I would have to use the breaking condition to illustrate that where I can print that the element is not found. As I have explained earlier, that L is always less than equal to U. L is always less than equal to U. So if the value of L is greater than U, if the value of L is greater than U, it is a breaking condition. So if I will write here if L greater than U, this will occur only if we have not got the element in the array. So here I will straightforwardly print that item not found. Straightforward I will write that item not found. That's it. Our program is end. So I will repeat the loop till the time the value of L is less than equal to U. If I found an element at the mid position, print that particular position, gets terminated. If it is not found, then we have two possibilities. Either it would be on the left hand side or it would be on the right hand side. If it is on the left hand side, L not updated, U updated to mid minus 1. If it is on the right hand side, U not updated, L updated, mid plus 1. And the loop repeats. When the condition L is less than equal to U fails, that means L is greater than U. That straightforward means that that particular item is not available in the array and I will print that. Okay? The complexity associated with this algorithm in terms of BIGO is order of log base to n. This is because at every iteration the array is being broken into different arrays of order of 2. That means in the first iteration, say it is of say n, then it is divided into 2 to the power 1, that is 2 sub-arrays. In the second iteration, it is divided into 2 to the power 2, that is 4 sub-arrays. Then 2 to the power 3, 8 sub-arrays till 2 to the power k. Okay? Now I am concluding the video, and on the next video, we will actually learn how to calculate the algorithm complexity of both the binary search and the linear search in both the best case, average case and worst case comparisons. Thank you and happy programming. Thank you.